I'm your host, Michael Callahan, and wherever you might be now, this is Where We Go Next. And Ben Lamm and George Church are co-founders of Colossal, a bioscience and genetics company that will rapidly advance the field of species de-extinction. Ben is CEO and is a serial technology entrepreneur driven to solve the most complex challenges facing our planet. Dr. George Church is Colossal's lead genetic advisor and the recognized leader in genomics, pioneering a number of advances and breakthroughs that have progressed the entire field. Ben, George, thanks so much for joining us.
Thanks for having us.
Great to be here.
Well, it's my pleasure. Now, if we had more time, I could easily devote an hour just to going through your respective biographies. Ben, with the companies you've co-founded over the last decade, from the mobile app innovator Chaotic Moon Studios to the machine learning tech startup Hypergiant Industries. George, with your decades of truly groundbreaking work in genetics, molecular engineering, and chemistry. Just a snippet of your biography for our audience. In 1984, you developed the first direct genomic sequencing method, which resulted in the first ever genome sequence, and are regarded by many as the, quote, founding father of genomics. You're a professor of genetics at Harvard and the director of the Center of Computational Genetics. And through the lab at Harvard that is named after you, you've co-founded about 50 biotech companies. So needless to say, gentlemen, your bona fides speak for themselves. But like many animals at risk of extinction today, our time is short. So let's get to it. As noted in the intro, Colossal is in the, quote, de-extinction business. And it's beginning with two animals that went extinct at wildly different times. The thylacine, commonly known as the Tasmanian tiger, which went extinct 86 years ago, and the woolly mammoth, which went extinct about 10,000 years ago. So, Ben, we'll start with you for the pitch, and then I'll turn to you for science in a moment, George. Ben, during a South by Southwest panel last year, you said, quote, "We're in the sixth mass extinction event, and this one's man-made. Between now and 2050, we as humanity are going to lose up to 50% of biodiversity on planet Earth if we do nothing," end quote. 30,000 species per year on average are being driven to extinction. That means about 6 will go extinct during the course of our conversation. So, Ben, what is de-extinction exactly? And how does it tie into another vital concept, the, quote, rewilding of endangered ecosystems?
Yeah, it's a great place to start. And so for us, George and I started talking about this business. We thought it'd be really great to build a company that de-extincted genes and built proxy species, which is what the core of our business is actually building proxy species for the mammoth, for the thylacine, looking at the core kind of phenotypes and physical attributes that, and obviously elephants make them cold tolerant and marsupials make them, larger, and hypercarnivorism and other attributes. And how can we use these extinct species to build these proxies that we can reintroduce back into the wild, which is a process called rewilding, where we actually reintroduce species back into the wild to kind of help fix that ecosystem. What was even more interesting, and one of the things that George and I have a lot of passions on, was that we could leverage the de-extinction projects to build these de-extinction toolkits that could be really used in not only ecosystem restoration work through rewilding, but can also help critically endangered species. So it gave us an opportunity to work on things like curing EEHV, which is a herpes virus, which kills about 25% of elephants every year. It gave us an opportunity to build next generation assisted reproductive technologies, which can be used in a wide variety of species, and really kind of opens the door to applying a lot of these tools and technology, many of which George had a hand in inventing in the early days and still continues to innovate now, to actually help critically endangered species. So we really saw an opportunity to build this de-extinction and species restoration company that focused on rewilding nature, for the benefit of preserving critically endangered species, but also for the purpose of helping restore degraded ecosystems like the Tasmanian forest, as well as the Arctic tundra. And so that's something that we got really, really passionate about, is how these things blend together. And it's been amazing, the feedback that we've received in market just on our short journey so far.
Ben, if I understand you correctly, what you're saying is that in the same way that, let's use as an example, the innovations born out of humanity's spacefaring missions have been used in areas of life that have nothing to do with space travel, the research that Colossal is doing in pursuing de-extinction of species like the mammoth and the thylacine can be used in other areas, like the vaccines you were talking about for elephants?
Yeah, absolutely. And so we have both conservation and human benefits. And so one of the things we announced earlier this year was anytime that we develop technologies for human healthcare that can also be monetized, whether that's software, wetware from the lab, or hardware, We spin those out. We create new companies. We did that with a computational biology platform called Form Bio that we spun out earlier this year. But what's really important to George and I is that, on the flip side of that coin, any technologies that have application to conservation, we're subsidizing. And we want to ensure that we give to the conservation community, for free. And we want to just ensure that anyone in conservation can use the technologies that we develop. And so we have the ability to do good, and also generate substantial technologies, which could also help human healthcare on the way.
George, de-extinction, or resurrection biology as it's sometimes known, has been a conservationist's dream going back decades. And in 2003, scientists briefly brought back a once extinct animal, the Pyrenean ibex, using somatic cell nuclear transfer, otherwise known as SCNT, the same technology used to clone the famous Dolly the sheep. But it only was alive for a few minutes before it died shortly after being born from a rather severe lung defect. Why is now the right time to try again to bring back animals like the mammoth and the thylacine? And how will Colossal succeed in its de-extinction efforts where others have failed? What's changed?
Quite frankly, bringing back something that's frozen, it really isn't completely extinct. But if it's all that's left of it is its DNA, then that's a different situation. And people have brought back frozen animals that are either extinct in the wild or endangered in need of new alleles. We're focusing on where we only have DNA available. DNA is available now. The record is 2 million years back. Just a few months ago was 1 million years. And it probably will keep getting older and older for a while. But anyway, we're looking to de-extinct genes, and we've done that, to enrich the diversity of modern endangered species, and possibly even modern non-endangered species. That diversity is important for adapting to new environments, changing environments, not just global warming. And I think that being able to harvest from all over the world and 2 million years back will be a great source of diversity. But we're not limited to that. As Ben mentioned, we can come up with new ways that aren't represented even in ancient DNA for protecting species from viruses, other pathogens, maybe extending their food range and so on.
Ben, let's talk a bit about Pleistocene Park, because I think that touches on something that George was just talking about, and something I know that you're passionate about as well, ecosystem restoration. Pleistocene Park, it's an Arctic tundra grassland restoration project in northeastern Russia, and it's where Colossal aims to rehome woolly mammoths once they're brought back. So to sort of get this out of the way, because it comes up in, I think, every interview I've seen with the two of you, it's almost like a meme at this point. And we've all seen Jurassic Park, but even absent fantastic science fiction, we've seen the havoc that can be wrought by introducing species to lands that aren't native to them. So while mammoths did once roam the Arctic tundra, Ben, what is the value in reintroducing them when they haven't touched the grasslands of Siberia for about 10,000 years?
I'll start off, but we should definitely also get some of George's perspective on this, because due to the war, we have not been over there. We were planning to go late last year, but that changed, given the conflict over there. George has actually worked with Sergei Nikita-Zimov, the founders and operators of Pleistocene Park, and also donated to it and worked with them for years. And he's actually been there. So we should also get George's perspective on this. And I do want to note that while we are focused on Pleistocene Park, we recently just got back from Alaska. We've been working with the head of Fish and Wildlife, some of the largest indigenous Arctic native corporations, which represent the indigenous people there, as well as met with one of the largest private landowners and whatnot. So we are looking, and we're starting those conversations also in the Yukon. So for us, this is not just an Alaskan thing. It's not just a Siberian project. This is not just a full Arctic Circle. We're also looking at Circle Polar North, which is a little bit broader than just the Arctic Circle region. So for us, and one of the original conversations I had with George was talking about the reintroduction of cold-tolerant elephants and functional mammoths that could be helpful for combating climate change. And what a lot of people don't realize is that there's more carbon stored in the Arctic than really anywhere else on the planet. And the Arctic's actually warming about 4 times faster than anywhere else on the planet. And so you've got a lot of trapped carbon and a lot of trapped methane there. And what's interesting is that this work that Sergei Nikita and their teams have done have shown that they've actually been able to lower, in peer-reviewed scientific journals, they've been able to lower ground temperatures by up to 8 degrees, which is really interesting. And that's a combination of them using tractors and other devices to remove some of the non-optimized carnivorous trees, as well as using the herding animals that actually help pack the snow in their herding in the winter months, that allows the cool Arctic breezes to penetrate deeper so you don't have that fluffy snow layer on top of the ground that's insulating. This actually allows the ground temperatures to get cooler so that when you go into the warmer months, that coolness is actually permeated deeper. And then they also help with the increased nutrient cycle. There was a great article, I think that came out yesterday, the day before, in Inverse, talking about how elephants are doing this, and they're studying this just in the African forest elephant in Central Africa. And so that increased nutrient cycling, making that permafrost in that tundra area less of a taiga forest and more of an Arctic grassland, increases carbon sequestration by about 6x. And then you have nearly a 2x albedo effect of light reflection back into space during the summer months. They've seen and done a lot of really interesting studies showing that this once Arctic mammoth steppe ecosystem was massively efficient at carbon sequestration and that nutrient cycling. And so there's been a lot of really interesting studies showing that elephants have been massively helpful in being environmental modifiers in actually knocking down trees and helping clear the landscape as they've done all over Africa. And so the combined kind of studies with the team at Pleistocene Park, well as some other peer-reviewed papers and some modeling that we've done with mammoth, shows that cold adaptive elephants could be a massive accelerant in resuscitating that ecosystem and helping with the carbon sequestration. And, George, you probably have additional points given that you've also been there.
Yeah, well, back to closer to the question about what could go wrong at Jurassic Park-like events. There are actually 1,000 different experiments on rewilding at this point, and I think they have all been successful. The only unsuccessful things were introduction of species that were invasive, that weren't part of a rewilding effort, but were either accidental or intentional, moving things many continents away. An example of a successful one was the reintroduction of the wolf into Yellowstone. After 70 years, it had impact on the herbivores that were keeping the willows and other trees from growing, not by killing the herbivores, but by chasing them away. They proliferated nevertheless. Then the trees grew to size big enough for beavers. Beavers changed the aquatic landscape for amphibia, fish, and aquatic birds. That's what you're looking for, is keystone species where influencing one species by rewilding can influence a lot. Now, mammoths or even dinosaurs in the Jurassic Park, with some thought about what would fit in with the environment that you're trying to recreate or restore, I think that that's generally gone well. Pleistocene Park is a really earnest and productive experiment so far of rewilding maybe a dozen different species. The only one that's missing is the one that knocks down trees and makes it easier for all the rest to do their job.
Yes, it's been interesting looking into the research and conservation that Sergei and more recently joined by his son Nikita Zimov have been doing in that area of Siberia since about 1996. For our audience, it's restorative work in a section of what is called appropriately, I think, the Mammoth Steppe. And these men and their teams have reintroduced animals to the area that once lived there, like the Yakutian horse in 1996, or they've brought in animals that had thrived in similar climates, like the musk ox in 2010, native to the Canadian Arctic. They've then introduced the European bison in 2011, yaks in 2017, and so on. I think right now, the area is home to populations of 9 megafauna grazers, which is 7 more than were once there. And again, I want to say that I'm framing these questions in a more skeptical way than I personally feel, because as I was prepping for this interview and asking friends and colleagues of mine what questions they might ask, there seemed to be, I think perhaps because Jurassic Park and more pessimistic science fiction of the last several decades has kind of primed people to be more skeptical of projects like this. If the process of reintroducing megafauna can help prevent climate change, negating the release of methane from permafrost, and these 9 megafauna grazers that are already in the park are helping to do that, the question from a skeptic would be, what role will the mammoth play that existing, currently non-extinct megafauna may already be playing in that area?
Based on their expectations, followed up by the actual experiments in Pleistocene Park with the 9 species that you mentioned, is that they don't knock down trees. They keep the trees at grass level so the grass can take over once they're knocked down, and knocking them down in the tundra, which is very uneven soil. When I was there, it's hard to negotiate even with a ATV, and the device that they were using to help them pull down the trees was broken and was not replaced. But elephants, for sure, knock down trees quite readily and could easily be encouraged to do it even more. They're usually used in the lumber industry in some countries, but they do it spontaneously. So I think that's what the other herbivores won't do. Even their large herbivores like the bison, they'll play around with sticks, but they won't knock down trees.
To your point on the critics, we actually love critics. And, many of the people on our scientific advisory board were early critics in this. But I think George and I have a general philosophy towards that is, you can learn from anyone. You can learn a lot more from an informed critic, right? And so we try to engage with those people and get feedback. And then, hopefully that continues to shape the mission more and more. And one of the things, to your point on the climate aspects of the project, we as Colossal are not going to solve all of climate change. This is one thing that we're working on. I'm sure you're familiar with the Paris Agreement. And what a lot of people don't know that came out of the Paris Agreement in 2015 was that 66% of the people that signed also committed to nature-based solutions in their climate pledges. So this wasn't just things like solar and going off fossil fuels and wind and other things, but it's also committing to reforestation, preventing deforestation, protecting wildlife, and rewilding initiatives, which 2/3 of the signatories of the Paris Agreement have also agreed to. So this is a nature-based solution. And we like to think of our approach as one of, hopefully thousands of other approaches worldwide that, hopefully will build kind of a tapestry of solutions to help combat man-made climate change and start to kind of reverse the damage that we've done. I think sometimes people get a little excited about our work and assume that it's a magic bullet and a true fix to everything. But really, there's got to be kind of a tapestry of these solutions, both technological as well as nature-based solutions that, really come together to help solve these problems.
That's very well said. I think it's easy for some of us to fall into the trap of looking at any one technology that is helping to alleviate climate change and being disappointed that that one technology in and of itself, whether it's solar power or ecological restoration, and saying, well, that's only doing 10% or 5%, or that won't get us all the way there. And I think looking at it from a more holistic point of view, where everything is part of a larger tapestry that prevents climate change is honestly the healthier approach. I'd love to get into to use a word that one of your lead scientists, Ariona Hisoli, used, juicy nitty-gritty of actually bringing back the woolly mammoth. So George, one of Colossal's lead scientists, aforementioned Ariona, who did research in Siberia with you, commented at a South by Southwest panel last year that you were on with her, Ben, that the tissues of the mammoths you found, some of which were up to 30,000 years old, were, quote, fleshy and juicy, end quote, which honestly surprised me as someone who's unfamiliar with this line of work. So how much of the original mammoth DNA is still intact, and how many gaps are there that will need to be filled in with Asian elephant DNA?
Some people imagine that we're getting these from fossils, which are actually stones. These are actually much more like frozen meat. The gaps, I think, is maybe another misunderstanding. That in any given cell, if you take one cell, it has two genomes in it, one from the mother and father, there will be breaks, maybe 1 million breaks, but they're not really gaps. There's just maybe one base missing out of the 3 million. And if you take millions of cells, which you typically do for sequencing the genome, then the break in one is covered by a solid piece in another. And the only gaps that remain are ones that are complicated by the computational methods that one uses for reassembling the genome. But the tools are getting better and better, and some of the quality of ancient genomes now is getting comparable to the quality of modern genomes. There were gaps in even the human genome until this year, and there still are gaps in clinical human genomes that are done on a routine basis because you don't need to get every last base pair. So what needs to be filled in by modern elephants? Well, first of all, they're already 99.6% identical. So whether you consider that filled in by one species or the other doesn't matter. And the remaining parts are mostly neutral. They just probably have no particular impact on the traits we care about, which is mainly cold resistance. So it may be 100 changes, it may be 1,000. We have editing tools we think that we've shown are capable of getting up to 24,000 edits in a special case, but we need to make that a more general technology.
I'm glad you brought that up, the 99.6% genetic similarity, because Ariona mentioned that same statistic. And so it kind of got me wondering. My question, again, coming from a layman's perspective, someone who is as familiar with this topic as one can be in a couple weeks of research, Gray wolves and modern domesticated dogs are, I think, 99.9% similar. And yet we can understand at almost a glance how different these animals are in temperament, ability, intelligence, etc. To put it another way for our listeners, chimpanzee and human DNA is 98.8% the same. But each human cell contains 3 billion base pairs, which are the building blocks of the DNA double helix. So 1.2% of difference equals about 35 million differences between chimps and humans. I guess, again, from the layman's perspective, even if Asian elephants and woolly mammoths are only 0.4% dissimilar, isn't that at scale still a huge chasm of difference considering how similar all beings on Earth are to one another?
One of the things that sometimes I think gets lost because of the excitement, once again, around the project is we aren't trying to bridge that 0.4%, right? We're not trying to clone mammoths, right? We're trying to, both with the Mammoth Project and the Thylacine Project, we're looking for those core phenotypes or physical attributes that represent what we're looking for, right? And so we do a lot of computational analysis, and then we can kind of identify what those genes are. With the mammoths, we've got a little over 60 genes that are kind of what we call our 1.0 list of editing that we're focusing on, which is much, much smaller than 0.4% of the whole genome. So as George mentioned, some of those edits aren't necessarily needed, especially if you're looking for, in the case of our Mammoth Project, the cold adaptive traits, right? Like how hemoglobin is produced at sub-freezing temperatures, the shaggy coat, the fat layer, and what have you. And so for us, it's less about bridging that 0.4% gap, which could be quite large, because we're not looking to make genetically identical species. We're looking for those core phenotypes. So that really allows us, from a computational biology perspective, to zero in on the number of edits that need to be made.
Going back to something you've said earlier in our conversation, the end goal of a company like Colossal is less about making an identical copy of something like the woolly mammoth, which may just very well be impossible, and more about, in this particular instance, making a cold adaptive elephant, which can help to restore an ecosystem like northern Siberia and keep the carbon dioxide and methane that's trapped within that permafrost, keep it there. It's not exactly about making a one-to-one woolly mammoth, although that might grab the headlines. It's more about making a creature, a cold adaptive elephant, that can survive in environments like Siberia.
Yeah, so to your point, we have kind of 4 primary goals, right? And so that's creating technologies which have applications to human healthcare on this path, creating technologies and giving to the world, as well as pursuing projects like the EEHV project that I mentioned that can help with conservation and subsidizing that. It's in developing these proxy species for reintroduction where they will have kind of that ecosystem restoration component. And then the fourth one is we do like the physical attributes outside of kind of the functional side. So, our goal with our, whether you want to call them functional mammoths or cold adaptive elephants or Arctic elephants, mammophant, we've heard a lot of different words around the years to describe what we're working on. But fundamentally, if it's cold tolerant, it has the functional attributes of a mammoth, and it also exudes those core physical attributes. When you see it, none of us on this call, to my knowledge, have seen a living mammoth, right? And so I think that physically it will look pretty close. And so if you create with these modifications and the de-extinction of these genes, you create kind of the physical attributes that you're looking for, and you also get the functional attributes that you're looking for. There's not really a strong purpose, at least in our company's vision, to continue on that path. Because if you have something that passes the grandmother test, looks at it and she says, wow, my grandmother says, wow, that's a woolly mammoth, and it passes kind of the Arctic restoration test, well, then I feel like we've achieved our goals.
Walks like a duck, talks like a duck, basically.
Yeah. To your wolf and dog analogy, like my dogs are rescues and they're about as muddy as mutt can be, but they're no less a dog than a wolf or anything else.
I would add to that even if our main goal is to have the function and physical attributes, I wouldn't go to the other extreme of saying it's impossible to bridge the gap. It's just not a high priority. And since we're working with technologies that are improving exponentially, both reading and writing DNA and testing them, it's not out of the question if somebody later wants to do it. But I think most people will be quite satisfied with what we're aiming for.
My follow-up question for you, George, is, as I mentioned earlier to our audience, this is the field of genomics that you've been in for decades. The research that you've done in various branches of this field is quite storied. So with this specific venture with Colossal, what is something, as your team gets closer and closer to making this a reality, What's something about this project that truly excites you, perhaps in a way that you haven't been excited about in one of your past projects?
I'm excited about the way that it benefits from technology we've developed for human clinical medicine. And I'm excited about the possibility of it repaying that debt in various ways, in particular, maybe in assisted reproductive technologies, but also multiplex editing. There are definitely things that we can do in the elephant, and we have done already in pigs that involve germline editing that we cannot do in humans, certainly are not rushing into the ethical issues with germline. We can do germline in pigs and elephants and dogs. So that's one thing. And the other thing is thinking deeply about ecosystems. Even if it's only a fraction of the tapestry that fixes climate change, I think it's one of the better ones that I've heard, at least on paper. A lot of them just slow down the inevitable, and we're already kind of too far in the sense that the Arctic is melting at 4 times faster than the rest of the world, and at a speed where there's 1,400 gigatons of carbon at risk, dwarfing the 10 gigatons per year that all humans combined produce. So those are the two probably most things that excite me.
The thing that the two of you, Ben and George, both keep circling back to is how something like bringing back the woolly mammoth or the thylacine, right, is representative of but a small piece of the grander project of Colossal. And I never would have thought about this until speaking with the two of you, but in some ways it feels like you're kind of swimming upstream from a marketing perspective, because all the headlines that I see about Colossal put something like the mammoth front and center as if it's all you're doing. And yet what the two of you keep reminding me and our audience is that no, our work with the woolly mammoth is circling back for other things that are related to other animals, other ecosystems, humankind, that the research that Colossal is doing is spanning a wide variety of areas. And yet it seems like every headline that I read about the company is focusing on just one tiny thing, bringing back the mammoth. Is that something that has been frustrating you from a messaging standpoint? Or how do you close the gap between what Colossal is actually trying to do and how it is perceived?
We've spent a lot of time on obviously having these conversations because we believe in radical transparency, and bringing back the mammoth and the thylacine and maybe additional potential species along the way that we're looking at is something that is core to the mission of Colossal. So I want to make sure that we don't belittle the fact that those are core to our mission. It's just there's a much larger, to your point, halo effect, Michael, that comes from these projects that we're really excited about. And so for us, one of the bigger things that is rarely mentioned is the excitement and rejuvenation around rewilding and around the application of synthetic biology to conservation, and just continue to put a spotlight on the fact that loss of biodiversity is a major problem. Also that's part of the climate disaster is also something that I think Colossal does a good job of doing. And I, for one, am fine with the headlines being whatever they need to be if it brings awareness and attention. What's been really interesting and really inspiring for me, and I assume will be for George, is like we get emails and letters of like little kids and their parents of kids that are drawing mammoths. And we get people that are pinging us on our email on social that are asking us questions about CRISPR. They're in high school, right? And so outside of the technical achievements that have applications to both conservation and humankind, as well as the ecosystem restoration, when you're working on something that's a moonshot, kind of like the Apollo program, I think you have an opportunity and almost a duty to message it, be radically transparent because, it's a bold initiative. But I think you also have an opportunity to really kind of educate the next generation in the success of our projects outside of the technologies and value creation and potential impact that we have, on the ecosystems as well as for our shareholders. I think that we also have, a huge opportunity to inspire in our success, bring awareness to these big, hard problems, and maybe inspire future generations to, have bigger solutions to some of these problems. Whatever gets people excited about science, especially in today's age, is something that I'm fine with. And as long as we continue to be transparent and educate the public, I think that hopefully that will continue.
Yes, the very idea of bringing back such a long extinct species like the mammoth taps, I think, into a deep primal part of the human imagination. So I am not surprised that you're getting letters from children who are imagining what the earth is going to be like once those mammoths one day return. We've spoken about CRISPR quite a bit during the course of this conversation. Specifically, the technology that's being used by Colossal is something called CRISPR-Cas9, a gene editing technology, which I believe was first developed in 2012. A brief kind of primer for our listeners. I got it from the Genetic Society. Quote, "The beauty of CRISPR gene editing lies in its simplicity. It's a simple system of precision-guided genetic scissors that can be programmed to cut any sequence of DNA. And once that cut has been made, nature takes its course, patching up the break with any DNA nearby that happens to match the broken ends. And if you provide a matching DNA repair template, complete with any variations or changes you want to incorporate, then those changes will be pasted back into the gene." End quote. Why is Colossal using CRISPR technology for its gene editing as opposed to another method like TALEN or ZFN? Is there something specifically about this method of gene editing that is preferable for the project of bringing back a mammoth or a Tasmanian tiger?
So my lab was involved in all three of those, the zinc fingers, talons, and CRISPR, and some others, both before and after CRISPR, such as transposons and integrases. And they each have different advantages, and we're not particularly stuck with one or the other. We'll use whatever works the best. For example, when you're putting in big pieces of DNA, as we did in the pig, we would put up to 20 kilobases of DNA in order to adapt the pigs for donating organs for humans. That is not necessarily best done by CRISPR. It's done by the integrases or the transposonases. We're going to use a mixture. Somehow the public locked into one of this toolbox full of tools. It's like saying, we now have a hammer. Now we can do any task we need to do. Or maybe an axe would be a better metaphor for CRISPR, because what it does straight out of the box is it kills viruses. That's what it evolved to do. And in our first paper in 2013 on this, it basically mostly was used for destroying genes. And we did show in the first paper that you could also do replacement, but that's much less efficient.
That's a really interesting perspective on that, because while trying to wrap my mind around these various gene editing technologies, it was hard while reading it not to take away as if they were somehow competing or like different brands within the same technological sphere, like Apple versus Google. But if I understand you correctly, George, it's better to understand them as different tools that can be all used towards the same goal. They're not necessarily competing technologies that are used in isolation.
Yeah, I think that's a good way of thinking about it. And they're even hybrid tools. So, for example, you can graft onto CRISPR or onto TALEN's deaminase, which changes a C to a T or an A to a G. Or you can graft on a recombinase onto some DNA specifying protein. So it's a very interesting toolbox now. And each year it gets more and more exponentially powerful.
When it comes to a project like this, there's that famous saying, there are known knowns, there are known unknowns, and unknown unknowns. What is something that could go wrong at one or multiple steps in the process, and how have you begun to plan for it? Because this is just still such a new field, still rather nascent. What are some problem solving that you're doing in advance of bringing back, let's say, the mammoth?
We're a big believer in parallel pathing, just like George talked about. The technologies that we're using in the editing are not solely limited to CRISPR. We're working on a wide variety of DNA synthesis, inserting large chunks of DNA and whatnot that George kind of mentioned. In addition to that, though, a big theme you'll see with Colossal is we're a big believer in parallel paths. If you ever tour the labs, we're happy to give you the nickel tour. I think you'll see that we already have a team that's working on the somatic cell nuclear transfer and the embryology on elephants, even though we don't have an embryo yet, right? We have a team that's working on wild type IVF and oocyte retrieval in elephants. And a lot of those technologies that actually have huge applications to elephant conservation. And so we're a big believer in kind of parallel pathing. And so we're not linearizing the work and just moving on to the various different stage gates. We're parallel pathing. And one of the things that we are working on, we know we can get to hundreds of mammoths and these other species the old-fashioned way, but we are also working on different approaches to ex utero development. And so the artificial womb work, I think is probably the hardest work that we will do. It's not fundamentally needed to get to success, to live birth, but it is fundamentally needed for us to get to, the scale function that we want to have a true material impact on the ecosystems, just given the long gestation of elephants and the time to sexual maturity in elephants being 12 to 13 years. We have a 17-person team, at Colossal. We've got people working on George's lab, got people working at Andrew Pass's lab in Australia, working on different paths on the ex utero development, everything from microfluidics and hydrogels and computer vision assisted kind of early stage development to full synthetic womb approaches to placental interfaces approaches, and everything from microprinting to engineering different tissue types. And George can get much deeper on the science of that. But those are things that, I think we are assuming the, intended success on the project. And so we're already doing the hard work now so that, 5 years from now, we potentially have some of the scale solutions solved. We are assuming success in the project and things look positive from where we're sitting today. But at the same time, we're starting to think through how can we parallel path the scale functions that we'll need for tomorrow.
Parallel pathing, I imagine it ensures that if you're going down multiple paths towards the same goal, that if one becomes foreclosed, you're not completely screwed. Is there anything that you wanted to add on to that, George?
Yeah, so the parallel path, it can be used both to do things that would be later, instead of doing them sequentially, we do them in parallel. But it can also be used, as you were saying, to protect and allow alternatives. So it's either changing the time frame, also providing alternatives. We also, are looking at other species. It's not just these two species. There will be others that we aim for. And it just may turn out that some are better than others. It could be that, for example, the elephant and the mammoth are very close to one another genetically and in terms of size and so on, while the thylacine doesn't really have a very close relative. The Dunart is, I think, 1,000 times smaller body mass and, maybe 5-fold more distant evolutionarily than the elephant mammoth distance. So there's a parallelization of species and environments that we're aiming for, along with the tools and the timing.
I should ask at least one rather fantastical question. Something that could be possible, if not now or even 5 years from now, but maybe something 10 or 15 years into the future as this technology continues to mature and you have successes in the future. George, you had mentioned earlier how what you found of the mammoth was almost like a frozen meat, like the kind you might find at the grocery store. Last year, I spoke with Justin Kolbeck. He's the co-founder of WildType. It's a company out of San Francisco that's using salmon stem cells to grow salmon flesh in a lab, completely removing the need for fish farming. So as these long extinct animals, and I know extinct might not be the right word exactly, but as they're brought back, do you see any potential for garnering popular interest in this project by collaborating with a company, let's say, if not specifically WildType, a company like it, to, I suppose, just to use the most blunt example, and with respect to your veganism, George, create other de-extinct meat that could potentially be used in a way that can help to raise money and awareness, et cetera, for these species as they're rewilded into ecosystems?
I think that's on the table. It's a possibility. In fact, the rewilding of bison, where there was almost none in the wild, maybe low hundreds in the world, now there's 500,000 in the world. That was largely driven by the meat being lower fat and cholesterol than their comparable bovine relatives. So I don't think it's out of the question. I do think that our fetish worldwide with meat is not entirely justified nutritionally. And in fact, it puts some people at risk, people with cholesterol issues. And I think we need to think more creatively about using synthetic biology to create the textures and tastes of meat in vegetables and improving recipes. But nevertheless, whatever it takes to get people excited, even more excited than they already are. And I think this project, for whatever reason, is exciting people even more than the Apollo project, the Genome project, and maybe even the smallpox project put together. I mean, we'll see. That's not a very rigorous statement, but it's a gut feeling. But if adding meat to it, cultured meat, cruelty-free meat, sometimes called, is certainly going to be easier than having a woolly mammoth changing the Arctic. We could make cultured elephant meat tomorrow. And I should mention, I've worked with Memphis Meats, which was one of the pioneers in this field.
What I've loved most about researching Colossal and your work, George, and the work that you've been doing, Ben, with the rest of the team, and all the brilliant, talented scientists who are working alongside both of you, is just that the more you understand about this field of research, the more vast the expanse of possibilities becomes, right? Because as you've said repeatedly in this conversation, it's not just about something like the woolly mammoth. It's not just about the thylacine or even other potentially extinct species that could be brought back. It's a holistic approach to a whole new field of research that can have many ramifications for all of us, animal, human, or otherwise. And I'm really excited about where we go next with this field of technology and your research. So thank you both so much for taking time out of your day. And thank you for honestly making me feel more optimistic about the future as it lays ahead.
Yeah, thanks, Michael, for having us. We obviously are pretty passionate about this and love talking about it. So thanks for having us.
Yeah, thank you.
Hey there. If you're hearing this, you're exactly the person this message is for. I want to learn more about the Where We Go Next audience, which means I want to learn more about you and your thoughts on the show. So if you're listening right now, please send me an email at wherewegopod@gmail.com and let me know, 1, what's your all-time favorite episode of the podcast and why? 2, what's your least favorite episode of the podcast and why? And 3, where would you like to see this show go next? And hey, while you're here, if you're a fan of the show, it would make my day if you could give it a 5-star rating and write a brief 1 or 2 sentence review on Apple Podcasts. It really does help. Thanks so much for listening. I look forward to hearing from you.